Hello, everybody. It's a big pleasure today again being with you guys. We have another presentation. Maybe this is going to be a little different, but we have with us Kenneth Teeters. He is the owner of Dandy Light Traps. He has been in the company for more than 25 years. And we have David Franco. He's an international sales for Dandy and a lot of experience. And today, David and Kenneth, they are gonna talk about the technology about the light traps. And like any other goal for poultry school, we would like to put in your hands technical information, practical information, and beside that, connect you with the companies and the people that they have the experience to support you in any other project. And in that way, I will leave you, David and Kenneth, and thank you for your time, and you're welcome.
Thank you.
Thank you. As Rodolfo said, my name is Kenneth Teeters. I'm the owner of Dandy Light Traps, and I've been in the industry for about 25 years. Dandy is the leader in light traps. We're the first company ever to develop a light trap. We've been in business for about 30 years. We are a family-owned company, and we work very closely with all the universities, University of Auburn, University of Georgia, NC State. We're actually the #1 light trap producer in the world, and we work with every integrator in the US. We've actually helped to write specs for most of the integrators, Tyson, Pilgrim, Sanderson, Case, and many of the others as well. So the first question we normally get is, what is a light trap? Well, a light trap is a product that allows air to flow through, but it also blocks light from entering. And the way that works is that air can make a turn, but light cannot make a turn. So when we design the light trap has 4 turns. And as the air goes through it, it can go through freely, but when the light hits it and reflects through those turns, it will dissipate light every time it hits one of the turns. And as it goes through, it will actually be completely taken away on the other side. Now, the degree of the bends in the light trap and the spacing in between the vanes, that determines how dark the light trap, but it also determines the airflow, which will in turn determine the static pressure inside your house. As you can see in this, in the picture here, what I was talking about, the air, when it hits those vanes, can make the turn and the air goes through the vanes. But when the light hits it and starts reflecting back and forth going through the trap, it takes away or dissipates the light. So what is the purpose of a light trap? Why do we use them, and what do we benefit from? So by blocking the outside light, it actually is what we're doing is giving the farmer control of the length of day. So the first thing that he'll use that for is developing the bird. So by controlling the length of day, he can ensure that the birds are fully grown and all of their parts and everything have been fully developed. Skeletal, circulatory system, everything has been developed. And then at that point, once the birds are fully developed, by controlling the length of day, they'll be able to control the sexual maturity of the bird. And we're actually manipulating the bird to believe that it's springtime. And when we do that, all the birds will start laying together, and they'll lay more consistently, and they'll lay longer because they were in the dark house to start with. So there's different light traps out there, but when you're trying to consider which light trap to use, there's 2 factors. Those factors are light reduction and then the airflow. You always hear light reduction as a 100 million to 1 or 200 or 500 million to 1 light reduction. I'm going to try to briefly describe what that means. So the minimum that's required in a pullet house is 2 million to 1. This has been proven by University of Auburn, University of Georgia. They both agree 2 million to 1 light reduction is all it's required. So what does that mean? So if you have a light trap that has a 2 million to 1 light reduction, and you're inside that pullet house, you will see that light trap. It will look like a large square. You will definitely be able to see that there is light, and you'll know exactly where it's at. That right there is the minimum requirement. In other words, that is dark enough to accomplish what you're wanting to do. Anything that is darker than 2 million to 1 is not noticed by the bird. So the question is why do we have, for example, our light trap is 7 million to 1? It's mainly because of us, the people. We look at it and we're like, oh, we can see that light trap. We don't like it. So we've had light traps get darker and darker, mainly for that reason. So now a 5 million to 1 or 7 million to 1 light trap, you would barely be able to make out just a very slight hint of a glow where that trap is at. So that is what that means when you hear that 2 million to 1 light reduction. The next part of the light trap is airflow. See, that's the, we're trying to get the best airflow that we can and still stay above that 2 million to 1 light reduction. So the better the airflow, the less static pressure that's going to be in the house, and the less it's going to affect your fans. That's probably one of the biggest questions that we receive at Dandy. They'll call in and people will say, how much is this going to restrict my fan? But instead of thinking, how much will it restrict my fan, we need to think, how much square footage of light trap do we need to put in to make everything work the way we want it to work? So what static pressure do you want in a pullet house? And where do you measure that static pressure? In this diagram, you'll see that you measure the static pressure between the false wall and the fans.
Kenneth, I think it would be, and allow me to interrupt, I think it would be interesting if you mention about why a false wall and not individual fans installed in front of exhaust fans. What is the benefit of having a false wall?
Actually, in this diagram, that's an excellent way to describe it. You'll notice you see cool cells, you see the brownout traps, but then a false wall. The false wall goes all the way across the house. The old way of doing this is you would have one fan and you would put one light trap in front of that fan. The problem with that is as soon as that fan turns on, then the fan is under whatever full static pressure that it's at, because it's only pulling air through that one light trap. So if you put a false wall, as in this diagram, all the way across the house, and you have 8 fans at the on the house, when you are only running 4 fans, for example, you're still pulling air through the entire false wall, and obviously a lot lower static pressure. The only time that the false wall is fully, we'll say, pressurized would be when all the fans are running. And then here at Dandy, we will calculate the false wall to be big enough to handle all the fans. So anytime that all fans are not running, you're actually at a lower static pressure, which enables the fans to be more efficient.
Well,
yeah,
and I think
go. I have one comment there.
Okay, and no, what I wanted to be to mention is, in order to be fair, if you, for preference or because of need, you don't have enough space to put a false wall or whatever, you have to install light traps in front of the fans. The right way to do it is to calculate the correct size of light trap in order to minimize the impact on the fan's performance. Correct?
Correct.
Yeah, my comment, Kenneth and David, like you were saying, when you are doing new projects, let's say brand new projects, it's easy to design. How many meters do you recommend from the false wall to the fans? 3 meters, something like that?
Normally it's 5 feet, 12, 3.5 meters.
Yeah. Okay. So, but one thing is, sometimes the growers, that's an extra cost in the building. And let's say in some point we need to justify it and to explain them that the extra investment for, let's say if that house is 14 16 meters meters wide by, let's say 3 4 meters, that's like 50 square meters extra in the house just to have that gap. And then obviously that gap of in the house also is for maintenance. If you want to do the maintenance for the fans, is an extra room, right? So in the real practice, when we go and we discuss about this system, we need to be clear how to justify this extra space in the building. Is if it's a retrofit, it is more difficult to justify it because the grower will put out, let's say, production area, right?
Right. But
Right.
Rodolfo, just to be clear, you don't need 3 meters. I mean, you need enough space for you to walk behind the false wall and do maintenance to the fence. It could be, I don't know, 5 feet. That's 1.5 meters. I mean, it doesn't have to be an enormous amount
Agree.
of space.
And,
You like 1 meter, 1 meter and a half.
Yeah,
Yeah.
exactly.
1.5 meters. Yeah, 5 feet is the normal, but also we run into that also, Rodolfo, the people not wanting to lose that floor space. So it doesn't work as well, but if you can just keep the light traps even 1 foot away from the fans, that still gives enough room for the air to flow through that false wall and still turn to go to whatever fan's running. So it's still going to operate better. But as you said a minute ago, having that the false wall away from the fans like that makes it so much easier. If you have a fan motor or
Agree.
something that goes out, it's much easier to get in there to do maintenance and to keep everything clean as well.
Yeah.
Correct.
Another thing that is really important for to point is that you can do the calculation of the amount of square feet of light trap according to any other fan in the market, right?
That is
That's
correct.
correct.
That's correct. What we actually prefer is if someone's building a pullet house and they want to do 450 feet per minute or 500 feet per minute, whatever airspeed that they want, if they'll call us to start with and say, here's the size of the house, I would like to have 450 feet per minute airspeed, we'll be glad to design it. We'll say, what fans are you using? We can tell you how many fans to put in, how much cool cell to put in, how much brown outlet trap to put in front of it, and how big the false wall needs to be for everything to operate correctly.
Yeah, that's very important. Thank you, Ken. Go
Yes.
ahead.
So, back to, so what we're doing is trying to get between a 0.15 and a 0.18 static pressure behind that false wall. And I thought I'd do just the next presentations to let everybody see how that works and how we're achieving that. So the cool cell in itself, if it's sized correctly, is going to add about a 0.05 static pressure to the house. If you have a cool cell, then you'll have to have a brownout trap. The brownout actually gets much better airflow than the cool cell does, as you can see, because it's only adding a 0.01 static pressure. Now we have to false wall. When it's sized correctly, we're going to add a 0.08 to a 0.09 static pressure with the air going through the false wall. And just pulling the air through the house, we will do a 0.02 to a 0.03 static pressure. So again, when all that's added up together, we're going to be between a 0.15 and a 0.18 static pressure.
Kenneth, I have another question.
Sure.
If you can go back, David, to the previous slide. In your experience, David and Kenneth, what is the most common mistakes that the growers do when they are doing these calculations? If,
Go ahead, Dave. In my opinion, they do not put enough inlet light trap.
That's right.
what I see more than anything is they do not put enough light trap on the inlet. And by doing that right off the bat, they're going to increase increasing their static pressure.
And I think it would be nice to mention a couple experience that we have visiting some customers in Latin America. Ken and I went to this customer and they were saying, well, we're having problems, huge static pressure. And Kenneth saw the house and just at that time he said, well, you don't have enough inlet. And they were like, no, we have enough inlet. I mean, we did the calculation. It was designed by whomever. So we ended adding probably 10 to 15 feet on each cool cell side of the house. And that, of course, adding the correct size of false wall light trap for the false wall solve the problem. I mean, but I would agree that, and also sizing correctly the false wall or the light traps that are going to be installed individually in front of the fan. Those are the two biggest issues.
And also in this drawing, we are showing a cool cell, but a lot of houses do not have cool cells. They'll just have a full-size light trap there. So that has to be calculated correctly. If you don't have cool cell, you have to have that light trap calculated correctly, and it needs to be large enough as well.
Ken, would you mind maybe mention the difference of brownout light trap and a max flow or full dark light trap? Because I think we did not mention that at the beginning of the presentation.
I don't know the picture that we showed to start with, the first light trap, that is actually our max flow. That's the full dark light trap. As you can see, it has 2 humps in it, and the spacing is 3/4 of an inch apart. By doing that, that gives us the darkness that we need and still gives the actual best airflow of any trap in the industry right now. The brownout light trap, I do not have a picture, but it's easy. The gap in between those are 1.5 inches between each vane, and they only have one single hump. And the reason for this is that the cool cell is going to knock out a lot of the light itself. So when you put the brownout trap in conjunction with the cool cell, that's what gives you total darkness.
Great. Rodolfo, any other question before we move to the next slide?
At this moment, no, I'm fine. Maybe later I will, I don't know if it's in the presentation, but I would like to go into maintenance, because that's another topic that maybe in all markets is manpower, right? Maybe you guys, you say, okay, this is the manual for your frequent maintenance, but one thing is the paper, but another thing is if they do it really in the farms, right? So maybe later we can discuss about maintenance. Go ahead.
I want to talk just a little bit about the fans in a pullet house, because as you can see, we're trying to get between a 0.15 and a 0.18 static pressure. So the fans that you choose need to work well under a high static pressure. So that's something to consider when you are picking out your fans. And also when you are calculating the number of fans that you need for a pullet house, always remember to use a 0.15 static pressure when you're determining how many fans that you need. Or to make it easy, you can call David and he will do it for you. The last thing is you always want to pull air through a light trap. You never want to push it. I have seen that in the past. We've gone to places and they are trying to, the fans are in like a positive pressure. They're trying to push the air through the light trap. It just does not work well at all to do that.
Well, Ken, I think maybe it's people doesn't think about this, but there's a right way and a wrong way to install a light trap. So especially we've seen in many houses that other vendors, other fan manufacturers, when they install the light traps in front of the fans, they place the vanes horizontally.
Oh, yeah.
Where they're supposed to be placed vertically. The fact that they are placed horizontally or vertically should not impact the performance in terms of the amount of light trap that they're going to reduce. However, if they are placed vertically, all the dust, all the dirt will fall, and it will be much easier to clean up and less subject to get clogged. And if the light trap gets dirty, normally or usually the performance decreases.
So as I was finishing up my presentation, light traps is used for total control in pullet houses. When I say total control, it has to be black. But I'm gonna let David talk here in just a minute, but the broiler industry, I mean, they're facing a huge problem of having excess light in them in their houses as well. And every integrator has their own lighting program, and they all believe their lighting program is the best. But every time the vents open, or every time a fan opens in the back of the house, they really don't have a lighting program, especially if the fans are on the end wall. The last 250 feet of the house in the summertime, especially when they're in tunnel ventilation and the fans are on constantly, the last 250 feet of the house, they don't even have a lighting program. So we do have a product called a fan shade that we do use in broilers now, and I'm going to let David talk on that one for a while.
Good. Before we move to the fan shade side or the broiler, do you have any question, Rodolfo, that you want to mention?
I have a couple question discussions and things that we have been facing for a couple years in the field. For example, I know that you guys you have a good product, but the thing is that
The
the light
best.
traps. Okay, sorry about that. So the thing is that, like just Kenneth was saying, to see and to experience the full benefit of your light trap, you need to deal with the quality and good design of the fans. Let's say the good maintenance of the cool cells, that maybe year after year the cool cells they are getting dirty, and maybe in some farms they have better management cleaning protocols, maybe another don't. And then the lighting program. So how do you guys interact with all these companies or suppliers to make a good program or practice protocol to the growers? Because I think that all those, let's say, elements needs to be aligned to the grower have the best benefit.
Well, what we recommend, and as you said, Rodolfo, what we recommend and then what people actually do are two different things. But we
Exactly,
recommend,
that's what I'm saying.
after every flock in a pullet house, most people and integrators require that they do a full clean out. But here we go again, a full clean out with one person might be something totally different to another person. And also we've seen people, like example, let's take a false wall. So after the birds go out, we recommend going in, blowing out, taking a blower and blowing out the false wall, starting from the top and going to the bottom. That's a minimum, at least blow it out. But we actually have farmers that will go in the middle of the flock with compressed air, and they'll blow them out mid flock. Obviously, that's going to be better. A lot of companies require that a false wall be pressure washed. And that's one good thing about our light traps. You can pressure wash them and you don't have to worry about the veins falling out or coming out of the little plastic or metal slots or anything like that. So it can be pressure washed and cleaned. As far as the cool cells, that's always an issue because the manufacturer recommends doing this to keep your cool cells clean.
Mm-hmm.
Very rare that you'll see people take cool cells out and do it unless they're really, really bad. They just leave them in there until there's no more air, and then they don't clean them. Then they throw them away and put new ones in. So it's obviously going to affect it.
And I'm pointing this because when you guys do like a new project and you play and you do the calculations with ideal conditions,
Right.
but how long those ideal conditions they're gonna be in the farm after 1 year or year and a half, right? And then maybe when David go or you guys go back and you don't see the ideal conditions that you expected at the beginning, that dialogue with the customer and maybe sometimes is kind of difficult, right?
Ralph, I do want to say one thing here, and David could probably back me up. When we do calculations, we actually take some of that into consideration because we calculate how many fans that you need at a 0.15 static pressure. But after we determine how many fans that you need, then we take those same fans at a 0.10 static pressure, which is going to be a high PM. And then we calculate all of the cool cells, the brownout traps, the false wall, everything in the house with that 10 static pressure, and it gives you a little buffer there. And that actually helps a lot with what you're talking about.
Yeah, and that's when we are working on a brand new project. I mean, but I would like to add to your question. We have a very good relationship with most of the fan manufacturers, to the point that several of them, when they have the option to put light traps in front of their fans, keep in mind that this is a game. This is a game between how big I can manufacture the fan just because I need the ideal size of light trap and how much it's going to cost to produce that ideal fan size to accommodate the light trap. So it's an economic type of discussion. So what we try to do is to tell them, look, this is the ideal size that you would like to place in front of the fan, and maybe find a sweet spot where the impact is minimized. But I can tell you, there's none fan manufacturers that uses the recommended light trap size in order to minimize the impact in static pressure on their fans. You find different sizes depending on the fan manufacturer. I mean, what I'm saying is the light trap size can vary between fan manufacturers if you select the same exhaust fan size. One of them can be a little bit bigger and the other one can be a little bit smaller. But ultimately, we always talk with, I'm going to say, the biggest players in the industry, and we keep a very open channel of communication. Of course, that's very important to Dandy.
Going to the market, guys. Maybe I may believe that the USA market at the beginning, the industry started using first the light traps first than Latin America. Do you see right now that the Latin America and USA markets they are equal in the technology and how to use light traps, or there's still a gap in between, let's say, technology?
Well, let me answer that question, Kenneth. I think the gap is getting very, very, very small. Latin American market is making a lot of progress. Of course, they will follow whatever we do in the United States in a good way. They of course tweak a little bit based on their reality. The cost of the product might be a reason why they don't implement certain type of technologies, but ultimately they want to achieve the same goals. And because of that, they're really close. Is not, if not at the same level in many of the things that they are doing in Latin America. One of the differences here, and Kenneth, you can correct me if I'm wrong. I mean, you know much better than me that the reality of the domestic market. But here, every project is mainly solid sidewalls. And in Latin America, we still use a lot of curtain material for the
That was my next
sidewalls.
question. Exactly.
Yeah.
Because sometimes you have curtains. Yeah.
But that does not change the fact that you can achieve the same goals. I mean, it makes a lot of sense for me because electricity or power reliability in Latin America is not the same as here. So if they have solid walls, they don't have a way to save those birds if they lose power. Even though when they have a backup of the backup of the backup for the generator, right? Sometimes that doesn't work, and if you don't have a way to open the curtains, the sidewall, you're running into a big problem, right? Here, power reliability is much better than in some of the Latin American countries.
And let me
obviously go.
And I was going to just to add to that just a little bit. Right now, we're talking about pullet houses. So as David's saying, pullet houses are very similar as what we're trying to achieve in the U.S. and South America. But if we're talking, and David's going to talk about it in a minute, as far as like the fan shades and for the broilers, actually, Latin America is, I would say, ahead in a way of the U.S. in using fan shades. And the main reason is because in the United States, the farms are not owned by the integrators. The birds are owned by the integrators, but the farms are not. And in lots of places in Latin America, the farms and everything are owned by the integrators. So they realize if you put a fan shade on there and you get 4, 5, 6 points better feed conversion, that's a lot of money they're saving. Whereas here in the U.S., the farmer would have to pay for that individually. And that works great. If one farmer puts it on his house and he pays for it out of his pocket, he's going to be better than all of everyone he's competing with. But as soon as his neighbor pays for it,
good point,
then they're right back to even. And what they're doing is they're just actually helping the integrator when it all comes down to it, because there's less feed that the integrator's having to supply. So
yeah, that's a good point, Kenneth. And that was another question, because maybe, David, the first time that I saw blackouts in broiler was in Colombia. Even they were doing the curtains, the drop ceiling, instead of being white Novatheme, there was black. In Brazil also, sometimes they are doing completely dark out in broilers.
Correct.
Right?
Yes. Yeah. The other thing I would like to mention is this biosecurity. I mean, in my opinion, again, I do not know as good as Kenneth the U.S. market, but the biosecurity measurements in some of the Latin American countries, Mexico, Colombia, Peru, Ecuador, where we have visited some of the houses, is way higher than here. I believe one of the reasons could be that they are more afraid, and it's hard for them to control any type of, things going on. But they clean up the houses every single flock.
Yes.
So, which is good. I mean,
you shower in and out of broiler houses in Latin America. You do not do that in the U.S.
So,
yeah, I agree. Shows one another question. David, are you gonna present something else, right?
Yes.
So Kenneth, between in the time that shows David start, how long it took to the US or to the industry to get to the technology that we have right now? Do you see any changes in technology in the future? Or
Yeah,
do you think that this technology is going to be steady?
I actually feel like it's going to be steady. The only when I first started, we only had one light trap design, and I actually went in there and modified that light trap to give better airflow. We went back and forth for many different designs, trying to come up with the optimal design that would give the best airflow, but still give the darkness that's required.
Mm-hmm.
And there's only so many different things that you can do to change that. So I feel like we hit the right mark, and the other people that have done light traps have well, they basically copied our design. So I don't think there's going to be a lot of improvement as far as in the pullet industry. That's why we were developing and trying to work on the fan shades for the broilers, what Dave is getting ready to go over.
Okay, okay. Go ahead, David.
Well, this is, and my presentation is in Spanish because I'm the Latin America international sales guy for Dandy. But I'll be happy to discuss and talk to anybody about this product. I mean, we talk initially, or Kenneth talk initially about the pullet side of the industry. I'm going to talk about a patented solution that Kenneth designed 6 years ago. Kenneth, remind me, correct? Right? That we've been positioning in the industry and in the market. And it was specifically designed for broilers. And Kenneth, jump in, feel free to add anything that I probably missed. It's called fan shades and side shades. The main product is fan shade, and the costing product is the side shade, which is used for the sidewall inlets. So these are patented and unique products in the industry that Dandy commercialized. The reason why Dandy designed this product was to specifically be used as a solution for broilers. Why? Dandy invested years trying to design a product that will solve some specific problems, specifically for the broiler houses. Well, we already talked about the pullets and the max flows and the light trap, full dark light traps for pullets. Those products are are more expensive than the products that we normally use on broiler houses. So we wanted to design something that it was less expensive, that they were easier to, another problem on the pullet world is that when you install full dark light traps, those products required installation, framing, a false wall. You have to invest more money into basically installing that product inside of your house. What other problem they face? Well, basically, as Kenneth mentioned, the light trap, they have an impact on the airflow. You can see there a false wall on a pullet house. This is the one on the left is a project in Mexico. The one on the right is a 2-tier light trap false wall project here in the US. So, of course, those false walls are properly sized, but the full dark light traps, they have an impact on the airflow. as Kenneth mentioned before. So we try to come up with solutions that specifically target those problems. So the fan shades are more economical, less expensive than a conventional light trap, full dark light trap. The return of the investment can be measured in months, and of course, it depends on the project. I mean, this is an average. We have worked with customers where we found out that the return of the investment, it was 6 months. But that's not, we don't want to use that as a standard. Is basically in a specific case. But the return of the investment can be measured and can be quantified, and we'll be happy to help the customer to estimate the return of the investment if they want to use our products. So
exactly. So sorry to interrupt you, David.
yeah.
That was gonna be my question.
Mhm.
How can you estimate, or how to use it, how to show the customer the payback?
Well, there's several factors. The first thing is, of course, we need data capture to compare the before and after. Before is a broiler house without the fan shades, without the side shades, and a broiler house with the fan shades and the side shades. There's data that's going to allow us to calculate the ROI. Some data is, I'm going to use the term tangible because you can measure it. For example, they improve on the feed conversion ratio, right? Another data is not that easy to measure, but if you have uniformity, if your birds are less stressed, if you prevent migration, that's going to give you better birds. If the birds are not scratching when the exhaust fans open or turn on, I mean, that is another way to estimate the benefits of the investment, right? But the main goal, the main thing you can measure is the return on the improvement on the feed conversion.
Yeah, and sorry to interrupt you. I'm pointing this because maybe in Latin America, maybe it's the market that I have been more related to. There are good companies that they have data, but there are other companies that they don't have data. So that's some kind of difficult.
And that has been one of the big problems we have, because we had experience with some well, integrators mean something different in Latin America than in the US, but we have a big success with customers that gather and provide that data. It's very easy to justify the investment, but when a customer does not gather, collect, or share the data, because one thing is you have it and you want to share it, and the other thing is you don't have it and, well, you can't share it, right? But when that data can be collected and can in a very good way, it's not easy. It's not very hard to justify the investment.
And it also depends on the type of house and how it's initially set up too, depending on if there's any dark out at all in the house. Or example, we did one project in Latin America that it was broiler houses. They did not have any light dimmers. They had clear curtains on the house. They had zero lighting program in that house. So if the sun was shining, the lights were on. And we took that house and we went from nothing, and we put black and white, we put black curtains on the entire house. We put fan shades, we put side shades, we put dimmers in the house and put lights in the house so they could control it. So we went from one extreme to the other extreme. But we also shown, correct me, David, it was like 11 and 13 point better feed conversion on multiple flocks If you use numbers like that, it doesn't take long at all to get an ROI.
Yeah,
Correct.
wow, yeah, that's a
I
good
mean,
point.
it was incredible. And then COVID hit right about the same time, and we had to put that particular test on hold. But that was I think 4 flocks that we did between 11 and 13 point better feed conversion, and that's incredible.
Yes.
It's incredible.
Yeah. Yeah. Correct. But that was going from one extreme to the other, right?
Most of the time we're seeing 3 to 6 point better feed conversion. And what a lot of people realize that when you put the fan shades on, especially the first flock, if you do not change your lighting program, your birds will be small because it's too dark in the house. You actually have to change your lighting program after you put the fan shades, because now you actually have the control that you thought you had to start with.
Yeah, we went for not being able to control a problem to being able to control that situation. And by control, I mean, we have to adjust the lighting program to a new reality, right? So it's not just put the fan shades and everything is going to be all right. No, we also work with universities and depending on the several factors, we suggest our customers, hey, look, this is a suggestion of the lighting program you should be using. It's just a suggestion. They can tweak it and find the sweet spot. And that's
the size of the bird mainly.
The size of the bird, the genetics, several things. Yeah. So
David,
okay.
right now that you point genetics, I assume that you work close to the genetics company, right?
Well, no, not really. I mean, we
Okay.
work in this case. We work with the integrators and the farmers and the universities. I mean, we take the genetics as one of the inputs based that we want to use to suggest the customers the suggested lighting program that they will have to implement after they install the fan shades.
Yeah, because I have seen every other genetic companies, they have their growth guide, right? And I assume that your
Yeah.
technology is in that guides, in some point recommendation according to birds and designs, whatever, right?
Yes. So
Okay.
I know we don't have much time, but I want to go through these slides really quick. And if you have a question, just let me know. One of the other things that we want to tackle, the problems that we want to tackle, is we want to provide a solution that is easy to assemble, easy to install, to clean up, maintain, and that do not clog. It's not going to restrict airflow, and the impact in that case will be marginal. I'm going to show a little bit of, there you go. The impact on airflow is 2.5%. That is very marginal. That is very, very small. And if you want to estimate the impact on static pressure is 0.01. So even for those customers that want to install the light traps on existing houses, they won't have to worry about adding additional exhaust fans to their houses because this product will not impact the fence performance or the house performance. So what is the ultimate goal? The ultimate goal is bigger birds, better mortality, improvement in the conversion ratio. Great. The fan shade was designed to redirect up to 95% of the direct sunlight. Just keep in mind, I'm not saying blocking, I'm saying redirecting. So the light will be redirected to the ceiling of the house. So at the bird height, they're gonna be able to implement a lighting program that works for that particular application. Two people can install a fan shade in 6-7 minutes, and put together a fan shade in 5-6-7 minutes and install it. As soon as you have the first one installed, it's very, very easy. I mean, you just need 5 minutes to install, and the product comes with everything you need to put it in front of a fan. If you see the pictures on the left, you'll see that basically we're covering each individual fan with a fan shade. So this is a video that I'm gonna leave there for everybody to see. This is basically how we install a fan shade. Everything that you see on this video comes with the product, the metal support brackets, everything. So it's very easy. You just put it in front of the fan. It is designed to, the space between the fan and the back of the side shade was designed and calculated to be the optimal space to minimize the impact on airflow and static pressure and maximize the light reduction, or in this case, to redirect the light. So you can see, very easy to install. One person can do it.
And this, David, this is just for broilers, right?
This is for broilers, but we found out that in some countries, like Canada and Colombia, they also like to use them on hen houses. They face a similar situation. The last group of cages near to the end wall, where the fans are located, when the fans are turned on, they get a lot of light. They get the performance of those birds are not the same. So they use, instead of building a false wall and going through the whole problem of calculating and making sure that they're going to get the same performance of the house, they just install fan shades, and they solve or at least they can handle that situation, that problem.
Great, perfect.
So it's also, it can be used on hen houses or layer houses. Okay, why we want to use fan shades? That's the same question as the light trap. So we have a representation of the house, and of course, when we turn on the fans, if the fans are located at the end wall, we're going to have light coming in the house, probably a third of the house. If we're lucky enough, we're going to have a quarter of the house impacted. Well, sometime somebody say, okay, we're going to minimize the problem by changing the fans from the end wall to the side walls. So that also minimize the problem, because the light coming in the house the problem is not that bad. Okay, we can have another conversation about a dead spot with air is not moving the same way as the rest of the house. But I mean, I'm going to leave that to the experts. In our case, the problem is light coming in the house, so you cannot implement a light program across the whole length of the house. So this is an example of a house running 19 fans running without shades. You can see the pictures. And this is the same house with fan shades. You can see the big difference. So as you can see, doesn't matter where you have the fans located, you are going to be able to minimize the impact of light coming in the house when you turn on the fans. That mostly when the birds are much bigger, you're going to have the fans running a lot of time on a broiler house. So by installing the fan shades, you're going to be able to minimize that problem and improve or at least have a consistent lighting program through the house.
And I assume, David, that you guys also do the calculation for air restriction, right?
Well,
Or
no, not really.
or there is not
There's really
not a air restriction for static pressure.
correct. It's a 0.25 reduction in airspeed and airflow. That's so minimal you can barely measure it. And you're adding, as David said, a 0.001 static pressure, which is barely measurable as well.
That's a very nice feature.
Yes.
Yes. So, and the causing products are called the side shades. The side shades are basically a similar solution, but you install on the sidewall inlets. It's the same concept, easy to install, easy to maintain. Basically, it's a very specific light trap profile that you install on the outside of the house. You don't have to do anything else. You just put the box that comes with the side shades in front of the existing inlet, sideward inlet, and that's pretty much it. I mean, as you can see on the top pictures, you on one side of the house does not have anything on, and the other side of the house, we install side shades. Those are different type of side shades. We have, angle side shades or straight side shades that the customers can use. A bunch of pictures and a link to the videos that we have posted and are available for our customers.
Perfect.
Any other question, Kenneth? Any other comment?
I don't think so.
Rodolfo?
Do you guys do any how do you transfer your technologies direct to your customers, or do you have a dealer network?
Our go-to market is always through our distributors. We always go through the market through them. We respect that, but what we normally do, part of our service is to go with them and educate, train, explain the benefits of our products to the end user. But we always going to rely on our distributors to go through the end user.
And what's the common rejection, for example, in the end customer that you can, let's say at the top of the mind, when you go and explain all your numbers and the technology, maybe where is the tough part from the customer not really going with the complete full solution?
No, it's too good to be true.
Okay, that's a good one.
No, well, joke aside. I mean, this is a new technology and it's not easy to implement. We have done many test houses in country with universities, and we like to go and talk to the customer and tell them, hey, if you want to try it, we're more than willing to do it. I mean, but the key part of trying is gathering the data. If that customer does not commit on getting the data, it's going to be very hard to justify the investment because the broiler industry is a completely different industry than the pullet industry. So if you cannot justify the investment, they're not going to do it.
Perfect.
And I just wanted to, this is part of the presentation, but instead of going to the slides, I want to show you the actual graphic. This is basically side by side. This particular this particular slide came from Auburn University. They conducted the test. The red shows the amount of light coming in the house. This is the length of the house. As you can see, using the side shades, you are minimizing the impact and reducing the amount of foot candles that gonna come in the house by a huge amount of percentage. So you are minimizing the impact big time. That is gonna give you the enough darkness to implement and a consistent lighting program.
This information is public, guys, or is just you
Yes.
have it?
No, this information is public. We have it posted on our website. It's available to anyone who wants to see it. We'll be more than willing to share that information with them.
Wow, very interesting. Okay, perfect, guys.
And I think that's it.
Okay, you hit 59 minutes and 35 seconds, right in between the eyes.
Yes.
1 hour of talking. So, guys, I'm really happy. I'm really excited about the information that you guys share. I think that was another commercial there, but you took off the screen.
Oh, well, yeah, that's I meant to say it, but that's another dandy company. So
okay,
maybe enough material for another podcast.
For another 1 hour conversation. Kenneth and David, I really appreciate your time. I think that this technology is really specific. And like we start this conversation, I think that the light traps in breeders is something that has been in the market for so long. And I think that you guys have been in the leader spot, and with technology and supplying the market, not just in the US, but globally and Latin America. But that's another part of the broilers and the chasing the broiler is very unique, I think, and that's part of our mission here in Poultry School, sharing fresh information, sharing innovation, and what we're gonna do when we post your video. If you're okay, we will post your emails. If somebody from our audience wants to reach you guys with more information, we will put your company link to any support that you guys can
Don't put my
provide.
email. Don't put my email.
Okay. Just David.
I was gonna volunteer Kenneth. We need to keep him busy.
Okay, guys. So
Absolutely.
So I think is a very, very interesting material. Myself, I have been a little bit in the industry, and I have never, let's say, seen this presentation, unless you go and find it and dig a little bit. And that's part of our mission, having like a online library that everybody can go and look the information from the experts. So David and Kenneth, again, thank you very much.
Yeah, enjoy
and
it.
I
Thank you very
appreciate
much.
it. And I really enjoyed this conversation, and see you around, guys. Thank you.
Thank you very much.
Thank you, Rodolfo, for the opportunity. We appreciate
Bye-bye,
it.
guys.
Thank you.
Thank you.